In this video, we're going to look at solving rational equations. And at the beginning of each equation, it's a very good idea to determine any excluded values. And afterwards, after you go through and solve using the properties of rational functions, uh, you want to check to see if any of the solutions you get match an excluded value, because that means that that particular solution that you found is not actually the solution. It has a special name. It's called an extraneous solution. And so it's not a solution to the actual equation. So for example, in the first one here, if I look at the fraction on the left, I see x minus 1 in the denominator. So I know that x cannot equal 1. That's my excluded value. I'm just going to write it for this time, just so you know the difference between excluded and extraneous. So excluded values are ones you do anytime where that would make the function undefined. That's an excluded value. So it's not part of the domain. So it's not a acceptable value here. So now when I want to solve this, I have a few different approaches here. Sometimes I can multiply by the common denominator, or in this case I can multiply both sides by x minus 1 and both sides by 4, which is the common denominator. And what we end up with is 4x on the left and 1 times x minus 1 on the right. And then if we simplify that, we see we get 3x is equal to negative 1. So therefore, x is equal to negative 1/3. This negative 1/3 does not match with an excluded value. So this is in fact the solution to this equation. Pause the video, try the one on the right, but make sure you include your excluded values. And as we can see, this one has a solution of x equals 1 with the excluded values of 0 and negative 3. So we're going to move on to this next one here. Now it's always a good idea to factor wherever possible to see if there's common factors, because it can make things a lot simpler when you're simplifying these. So what I'm going to do is I'm going to factor any of these if I can. This side, the left side I can't, but on the right side I can factor the denominator. And I see I get 2x minus 5. So here I can find my excluded values. I know that x cannot equal 5. And we see we both have an x minus 5 term in the denominator, which means if I multiply both sides by x minus 5, they will divide on each side. So really all I need to do is multiply the left side by 2, and the right side would stay as such. So now I have 6x plus 14 equal to 5x plus 17. I'm going to subtract 5x by both sides, and then we subtract 14, and I get x is equal to 3. And again, this does not match my excluded value, so that is in fact the solution to this equation. So pause the video and try the one on the right. Here we see x is negative 17 over 14, and that doesn't match excluded, so that is the solution. All right, we'll continue with these ones here. So this one here, I see, the x squared, and x. But I know that x cannot equal 0, so that's my excluded value in this case. Now there's a few different ways to approach this. One way would be to combine the fractions on the right side together, to combine those into one fraction. And so what we would do is we'd leave the 1 over 6x squared here, and we would combine these together, and we would do that as 3x squared as the denominator, meaning we would have 1 minus 3x over 3x squared. So I'm using the principles of adding and subtracting rational functions. If you're a little confused on that, make sure you go back and check out that video on how to add and subtract rational functions. But basically, I multiplied the numerator and denominator by 3x to get a common denominator of 3x squared. Now I can do a few different things here. I see that both denominators have an x squared and both have a common factor of 3. So if I multiply both sides by 6x squared, or if I multiply both sides by 3x squared, that would divide out. So really what I need to do is do 1 equal to 2 times 1 minus 3x. And that would ultimately divide out. Then we get 2 minus 6x is equal to 1. So negative 1, negative 6x. So x is equal to 1 over 6. And that is not 0, so that is an acceptable solution. So pause the video and try the one on the right. And so for that one, we get an answer of x is equal to negative 1/2. All right, so let's go ahead and do this. Now on the left side, we see we have denominators of 4, and the right side is 4x. So again, that's an excluded value of x equal to 0. Now we're going to combine these. They already have a common denominator, so we don't need to do any extra work. So we end up with x plus 4 plus x minus 1 all over 4 equal to x plus 4 over 4x. And if I simplify this, 2x plus 3 over 4, so x plus 4 over 4x. Now if I multiply both sides by 4x, I'm going to write that out here. So this is what we're actually doing. We multiply both sides by 4x. You see that this 4x would divide by this, and this 4 would divide with that 4, but we'd be left with an x there. So that gives us x times 2x plus 3 equal to x plus 4. So we got 2x squared plus 3x, and we're going to subtract x and subtract a 4. I'm going to do that in one go. So we have 2x squared plus 2x minus 4 equal to 0. That has a common factor of 2, and if I divide everything by 2, I'm left with x squared plus x minus 2 equal to 0, and that would factor to x plus 2, x minus 1 equal to 0. So therefore my two solutions are x is negative 2 or x is 1. Both of these are solutions because they do not match the excluded values. Right, pause the video, try the one on the right. All right, so again, we combined the terms and then we multiplied it by the common denominator. And in that case, that got us to a quadratic equation that looked like this. And we couldn't factor that, so we ended up using the quadratic formula. And root 108 would simplify to 6 root 3 because 108 is 36 times 3 and the square root of 36 is 6. So it's root, and then I divided everything out. We had a common factor of 2 in all the terms, and so we end up with negative 1 plus or minus 3 root 3 all over 2. In this scenario, we have two fractions equaling each other, and we don't have a third fraction complicating things. So at this point here, cross multiplication would be an appropriate method. So really, we multiply both sides by x squared minus 2 and multiply both sides by x minus 2. So we end up with 4 times x minus 2 equal to 1 times x squared minus 2. And then I'll expand these brackets. 4x squared minus 8 is equal to x squared minus 2. I'll bring this over, so I have x squared minus 4x, and then I have plus 8, so that's plus 6. And then again, I'm looking for factors that give me positive 6 and negative 4. So two numbers that multiply to 6 and add to negative 4. And there turns out there's nothing we can do for that. So again, we're going to have to use the quadratic formula here. So we get x is equal to 4, negative negative 4 plus or minus negative 4 squared minus 4 times 1 times 6 all over 2 times 1. And that's going to get us 4 plus or minus, and if I do negative 4 squared, that's 16, subtract 24, that's negative 8 all over 2. And so I'm going to bring out the So I'm going to do a bit of simplifying here. I know that 4 is a factor of 8, so I can simplify this to 4 plus or minus 2I root 2 all over 2, and then I can divide the 2 into these, so I get 2 plus or minus I root 2. And at the beginning I forgot to check, but I should put my excluded values here. So my excluded values are x cannot be plus or minus the square root of 2 or 2. Now these two solutions don't fall into that category, so these are both solutions to the equation. So pause the video and try the one below, or to the right. So as you can see here, we get x equals 4, but in the beginning we should have had x cannot equal 4. X is one of our excluded values. So in fact, this is extraneous. So in fact, there are no solutions to that equation. Okay, lastly, we want to add all these up together, combine them, and then see if we can solve it. First thing we want to do is factor any quadratics we have, and that way we can look for terms that are already in common, so we know we don't have to multiply more than one thing twice. So I'm going to simplify this fraction on the left by writing it as x minus 6, x minus 2, because that's how I would factor that. Now I have x minus 2 plus 1, x minus 6, and I can make the right side of this equation have a common denominator and combine those together. So I have the 4 here, x minus 6 times x minus 2 equal to, and the first term I'm going to have to multiply by x minus 6, and the second term I'm going to have to multiply by x minus 2, but they will now have a common denominator of x minus 2, x minus 6. And similar to the previous example, we see they both have the same denominator. And if the denominators are same on the equal sign, that means that the numerators are equal. So we can think of this lots of different ways, but ultimately we could write this as 4 equal to x times x minus 6 plus 1 times x minus 2. And then we'll expand this out, x squared minus 6x plus x minus 2. And then I will have 0 equal to x squared minus 5x minus 6. And I'm looking for factors that would give me negative 5 as a sum and a product of negative 6. And that would be negative 6 and positive 1. So I have 0 is equal to x minus 6, x plus 1. So therefore x is 6 and x is equal to negative 1. However, if we look back up at the top here, our excluded values should have been x cannot be 2 or 6. And so this one here is an extraneous solution. So that is not a solution to this equation. So the only solution is x equal to negative 1. Pause the video, try the one on the right. So in this scenario, we have our excluded values of negative 3 and 2. And when we simplify this down, we get two solutions of x is 0 and x is 5. And neither of those match our excluded values, so those are solutions to this equation. So when solving rational equations, make sure at the beginning you include your excluded values, and that way you can check later on if they are in fact solutions or they are extraneous solutions.